In this video we're going to cover horizontal translation of cosine and sine functions. And again, the idea is that in pre-calc we've already learned about horizontal translations. For example, if we have a toolbox function f of x equals x squared, we know that if we add or subtract a quantity to the input variable, that doing so translates horizontally the graph of the toolbox function. So for example, if we have x minus 2 squared, this takes the graph of x squared and translates it 2 units to the right because of the subtraction. Similarly, if we have a function h of x equals, let's say, x plus 1 quantity squared, this translates the graph of x squared over 1 unit to the left because of the addition. So what we learned in pre-calc about horizontal function translations that occur when we add or subtract some real number from the input variable, those principles are going to hold up in the context of trigonometry as well. These are trigonometric functions, and function transformations will apply to these functions just as they did to the toolbox functions you learned in your first pre-calculus course. The thing that we need to be careful about is when we have a multiplier on the input variable that's causing a change to the period. We know that there's a function transformation, a horizontal translation going on because of this minus 4. But if there's a multiplier on the input variable, we don't know the horizontal transformation or translation until we factor this 3 off. In other words, what we want to determine or ascertain is what quantity is being subtracted from a single x. Right now we know that 4 is being subtracted from 3 x's, but we need to determine what's being subtracted from a single x in order to determine our horizontal translation. So the way that we figure this out is we just factor the 3 off of the x, and if we do that, that's going to leave an x minus, and then we'll get 4 over 3, and we check our work by using distribution. So if I distribute 3 into x, I get my 3x back. I have my minus, and if I multiply 3 times 4/3, I get 4. I get my 4 back. So this right here tells me that my graph is shifted 4/3 units to the right because of the minus sign. So subtracting 4/3 takes the graph of my function and subtracts and translates it, 4/3 units to the right. So the easiest way, I think, to graph a horizontally translated graph, if it's been translated to the right, and to get one full period of it, is to just establish your x and y axes. Step 1. There's no vertical translation here to deal with. So this is just a horizontal translation occurring because of the subtraction from x. So let's establish our coordinate system. Here's our x-axis. So we have established our coordinate system, and we know that the graph is translated 4/3 units to the right. So just put a tick mark in to establish that 4/3. And then what we want to do is graph the sine function with, instead of starting at the origin like it usually does, we're going to start at 4/3. So we're taking the origin where the sine function usually starts and saying, hey, that origin's getting shifted over 4/3 of a unit. We're going to start the sine function right there. And then I see a minus, which I know is reflecting the sine function over the x-axis. So I start here instead of at the origin, shift the origin where the sine function starts. Usually -4 times sine, we would go like this. But instead we're going to move over our shifted amount, 4/3, and then just draw what the sine function is supposed to look like if it's reflected. Instead of going up, it goes down to its low point, comes back up to its midline, it goes up to its high point, and comes back down to its midline. We know the amplitude is 4, so we know that the highest point on the graph is going to be at 4, and the lowest point right here is going to be at -4. And then what we need to do is figure out what the period is. What is the distance between the beginning and when we wind up back where we started. So to do that, we just look at the 3 times x. This 3 is changing the period. Usually the period is 2 pi, but multiplying x by 3 makes everything happen 3 times faster. So we say, when does the 3x equal 2 pi, which is 1 full revolution around the unit circle? And then divide by 3. We get 2 pi over 3 is 1 period. And what that tells us is that the distance from 4/3 to where we return to where we started is going to be 2 pi over 3 units. So to figure out the tick mark right here, I just add 2 pi over 3 to 4/3. That would be one way to do it. Or I know that one period of my graph is broken into fourths. So high point, midline crossing, low point, midpoint. It's broken into 4 pieces. And to find out the width of one of those pieces, we just need a quarter of the period. So I can say, what's a quarter of 2 pi over 3? Well, that's going to equal pi over 6. So this distance here is pi over 6 units. In fact, the distance between each of these is just pi over 6 units, which adds up to 4 pi over 6, which reduces to the 2 pi over 3, or 1 period. So to get the next tick mark, I just add pi over 6 units to 4/3. So I go 4/3 plus pi over 6, get a common denominator. It's going to give me 8 plus pi over 6. This tick mark right here is going to be 8 plus pi over 6. And this next tick mark, I just added another pi over 6 to this. So 8 plus pi over 6 plus pi over 6. If we think about that, 8 plus pi over 6 plus another distance of pi over 6 is just going to give us 8 plus 2 pi over 6. We get pi plus pi is 2 pi. So right here we're going to get 8 plus 2 pi over 6. And this one's going to be 8 plus, we're going to add another pi over 6, so it's going to be plus 3 pi over 6. And this last tick mark right here is going to be 8 plus 4 pi over 6. And some of these fractions, or some of these ratios, could be reduced. This one could be reduced, and this one could be reduced by factoring out a 2 and canceling it with the 6. This one couldn't be reduced. This one right here can be reduced. We could factor out a 2. I don't think that that's necessary. So there's a nice graph of a sine function that's been shifted horizontally 4/3 units to the right. So again, if it's a rightwards translation, then to graph 1 unit of it, I think you just put your tick mark in right here and draw what the sine function should look like. The next example, we're going to have a left shift, and I think it's easiest to deal with these a little bit differently. And I wish I would have put function notation on that. So we play the same game that we did on the previous slide. We want to figure out what the shift is. I see the amplitude's 3. There's no negative sign, so we're not reflected. So I get 3 times the cosine of 2x plus pi. And I want to factor the 2 off in order to identify how big the shift is. So factoring off a 2 is going to leave me with x plus pi over 2. And this is positive, so it's a shift to the left of pi over 2 units. And then what I like to do sometimes is draw what the graph would look like if it weren't shifted. So draw the graph of 3 cosine of 2x and see what it would look like if it weren't shifted by pi over 2 units. What would that graph look like? Because it can inform the graph of the shifted one, especially when it's a shift to the left and we have to deal with how the function is crossing the x-axis. We want to try to get that the y-axis. We want to try to get the y-intercept as as accurate as we can. So if I were just to graph f of x equals 3 cos 2x, say, what would that look like? Okay, well, there's no horizontal shift, and we've already learned how to graph these. The cosine function starts high, it goes to its midline, it goes to its lowest point, back to its midline, and returns to where it began. And this would be going from 3 to negative 3 because we have an amplitude of 3. And then this 2, this multiplier of 2, makes everything happen twice as fast. So if it's happening twice as fast, instead of everything happening that's going to happen in 2 pi radians, it should happen in pi radians. We could verify that by just saying, hey, when does 2x, when does the input of the cosine function equal 2 pi, which represents 1 period? And then divide both sides by 2. We get x equals pi. And then I know when I break this up into fourths, the 4 equally sized chunks, that I'm going to be multiplying the period pi times a fourth. So a fourth of pi is just pi over 4. So this would be pi over 4. This would be 2 pi over 4. Let me put, whoops, I'm killing my sine function. This would be 2 pi over 4. Notice that this reduces to pi over 2, which is exactly the shift. We're shifting by pi over 2. And then this tick mark would be, this is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which reduces to pi radians. So we know that we have a shift to the left of pi over 2. Our graph is shifting left pi over 2 units. So that tells us that this point right here, which happens at pi over 2, if it's a pi over 2 unit shift to the left, this point is going to get shifted all the way over to the y-axis. So the whole graph shifts over. All the key points shift over pi over 2 units, which is the distance from here to here. So now I can draw my graph. I can say, hey, here's my horizontal axis, drawn poorly. Here's my horizontal axis. Here's my x-axis. What does the cosine function look like? Well, it looks like this. I'm just going to draw it. It looks like this. It looks like this. It looks like this. Back to where we started. And then this point is getting shifted over to pi over 2. That tells us that the y-axis is going to come down through this point. So notice how I drew the picture. And now I'm going to draw my vertical axis into the correct position based on the picture that I drew. And now I can finish up my labeling. This is f of x. There's my x-axis. I need to figure out these key points, but I know that they've all been shifted pi over 2 units. I also know that the distance between each tick mark is pi over 4. So this is negative pi over 4, negative 2 pi over 4. This would be negative 2 pi over 4. This would be negative 1 pi over 4, negative, here, well, not negative, but 0 pi over 4, pi over 4, and 2 pi over 4. And I could reduce this and this if I wanted to. And now I need to mark in my amplitude. It's going from 3 to negative 3, and now I have a correctly shifted, 1 period of a correctly shifted graph of the cosine function.